Hello all, and welcome to this mini lecture, which today is going to be about symmetrical modeling and what are the available tools in Alias to work with symmetry. Now, working with symmetrical model is very common in Alias and in other systems as well. Usually we work around the XZ plane, and I'm going to show you some tips and tricks here. So let's get started. I'm gonna go to the back view and just quickly draw up a CV curve with new curves, new CV curve. We can make it a degree 5. Go. I hit Alt to snap it onto the grid and make sure it's sitting on the symmetry line here, the z-axis, and then just throw out 3 more CV points like that. So we have a curve here. Now, normally, if we would like to have a symmetric version of this curve, we would then go Edit, Duplicate, and Mirror, and get a copy of this curve in the mirrored plane. This, however, has its disadvantages, namely that if we modify the curve on this side, the other one does not follow. So this is not really what we're looking for here. So I'm going to get rid of that one and go to Layers and Symmetry. And in this, under this menu, there is a function called Set Plane. This is where we set which symmetry plane we want when we work along here. So what we get here is a number of symbols, plane symbols. You see 3 of them, the little black ones here. So I can choose those, or I can rotate this plane any way I want, or select another plane defined by some other geometry or whatever. In this case, we want the XZ plane, so I click this symbol and it turns yellow. So now we've set the desired symmetry plane. So if I then go back to the ISO view, or the back view here, I can then, using layers, this curve was created in a layer called curve right here. So if I right click this layer here, I get a selection of menu objects here where one is symmetry. So I hit symmetry and voila, I get an image of this curve mirrored in the XZ plane. Now, this is not really a geometry, it's merely an image. And by doing it that way, if I then manipulate this side of the curve, the other side will follow, which is very nice. Now, please note that this is no guarantee that we have tangency over the symmetry plane or curvature over the symmetry plane. As you can see, when I move this CV right here, it will have a tangent error in the symmetry plane, but it is symmetrical, which is very nice. If we move out to the perspective view again, let's see if we can find this curve here. There it is. And we temporarily shut off the symmetry visualization of this layer. So we're back to one curve again. I'm going to create a surface here. Let's see how that works with surfaces. So I pick this curve, make a copy of it, Control C, paste it in, Control V, and I move that slightly in the X direction and move it slightly upwards. And I take a copy of that one, Control C, and then paste it in, Control V. move it in the X direction and slightly downward, something like that. We can then use, for instance, the skin tool. I hit the first curve and then hold down shift and hit the other two curves. Then I get a smooth transition between these three generating curves. We now have a surface here, which if I turn on symmetry in this layer, will be shown as symmetric. However, we know little about what is happening here in this region between the original surface and the mirrored surface right there. Let me first get rid of the curves that I just used to create this one and just keep the surfaces like this. Also, we need to visualize the CV points. Now, note that the CV points are only visible for the original surface, because this is not a surface. As I told you, this is a visualization of this surface mirrored. We turn off the CV points again, and we shade the surface up and have a look at it. Get rid of the model, and we spin it around, and we can clearly here see that we do have a tangent error along the symmetry plane here, which is not acceptable. So we can try to fix that with a quick fix. We bring back that one again, pick the surface and turn on the CVs. Tangency is controlled by the second row of CV points here. So what I can do is to try and manipulate these three and see if I can obtain a tangency between these two surfaces. In order to do so, I need an analysis running while I'm doing it, and that can be done using the evaluate continuity and surface continuity. Continuity is the correct word here. I use the G2 curvature continuity, show max labels, and also comb, which will graphically show us the error if there is one. I go and click on the border between the two surfaces, and we do have a tangent error here of about a degree. So as little as 1 degree difference between these two gives us a clearly visible tangency error. Okay, so what we need to do then is to pick this hull right here. A hull is a row of CV points, namely these three. So I need to move them in the Z direction either way to try and get that angle below 0.1 degrees. See if that is doable by using the X-form tools. So I go X-form move and I right click to restrict the movement in the Z direction and see what comes here. Oh, that's tricky. We need to zoom in pretty hard here. So we zoom in on the analysis and we try to bring that angle down to below 0.1, and there we go. So that was pretty easy to fix. Now, if I feel I'm done here, remember I told you that turning on symmetry here does not mean that what we see on the other side is a geometry. We need to create that geometry somehow, and that can be done very easily. So what we do is that for the layer we want to create the geometry, we turn on the symmetry as we've done here, and then we go to layers, symmetry, and create geometry. What that does is that it actually creates a surface replacing that image of this surface that we saw earlier. Now we have two surfaces that are independent from each other, but as long as I don't touch them, they will be symmetric over the XZ plane. Thank you for listening. See you soon again.